Hello student, today we are going to study the cure algorithm, but before starting that we understand that what are the basic categories of the clustering techniques. Clustering techniques can be divided into two classes, the partition based clustering technique and the hierarchical agglomerative techniques. In partitioning technique, we start with the partitioning the original data set into smaller clusters and we keep on continuing partitioning. While on the other hand, in hierarchical agglomerative techniques, we start with the small, single point clusters and step upward step by merging these clusters until the desired number of cluster is reached. In the cure algorithm that we are going to study, we are using the technique of the hierarchical agglomerative clustering, and, but we have want to study that what are the advantages. The cure algorithm is the very efficient technique for and fast technique for processing big size data. We have already studied a lot of clustering technique like BERT, DB-scan, K-mean clustering that have been using the hierarchy clustering technique, but it has the advantage over that. Since in the last, it is very much faster in comparison to the other technique. Then what is the advantage? Again, before discussing all these, we want to say that all the technique that I have named here were either they were using the concept of the centroid based approach. In the centroid based approach, we assume that the cluster is represented by the center of that cluster. Means we, like in k-mean or the brick algorithm, we find out the coordinate of all the points and we take the mean of the x coordinate and mean of the y coordinate, and then the point is the x mean and y mean is considered as the centroid, and this centroid is used to represent the cluster. This technique works very well with the symmetrical clusters which use symmetrical shapes, but this technique is not efficient in case of irregular shapes. As in irregular shapes, it is very difficult to find out the mean of the x coordinate and mean of the y coordinates. Since in irregular shape, it is much difficult to calculate the mean and y mean, and it is also very time consuming. So the centroid, and it is very take a lot of computation to calculate the mean. The another approach that is used is the all points representation. In all point representation, we as you consider all the point that lies inside the cluster, and this technique is gives you accurate result, but this is very inefficient because if we consider each and every element for representing a cluster, then it would be too time consuming to perform. To perform. So, what will be the optimal way to represent the cluster? The centroid based approach, yeah, or all point based approach. Each one has its own advantage. In centroid based approach, is efficient in case of symmetrical, but in case of non-symmetrical, it is very not accurate. And by all point representative approach is very accurate, but it's too time consuming. And since we are dealing with a very huge amount of data, so we cannot deal with the all point approach. So the cure algorithm find a path in between these two. In the cure algorithm, the instead of taking a single point or all point, we take the some few representative points. We select some few representative points through the some random algorithm, so which are used to represent the clusters. And this technique is also very sensitive to the outlier and of the change in the data approach. The consideration of the outlier is very efficiently done by this algorithm. So we can say that the cure algorithm is a new hierarchical algorithm that adopts the middle ground between the centroid based approach and all point approach. In a constant number of C of well scattered point in a cluster are chosen as representative. These points catch all the possible forms that could have the clusters. In it, we select the C number of representatives, and these are calculated through some algorithm that use the all the possible point that the cluster could have, or similar point that the cluster could have. The cluster with the in it, after selecting the representative, we check out that the rest of the element which have not been chosen as the representative element, that to which of the representative point they are closer with. All the points which get attached to the representative point with which they are closer rather than the rest other ones. In this way, every endpoints becomes connected, get connected to some of the representative points. And before doing all these, the first step that is done by the cure algorithm is the sampling and partitioning. In this diagram, I'm showing you the cure architecture. In this, the data is we take the random sample and partition the sample in some p number of partitions. Suppose there are n number of data, then we divide them into the n by p number of partitions, p partitions, and after doing the partitions, we again perform partial clustering inside these partitions. The point, make sure clear it here that the inside the partition we create partial clusters, and if the point there is a clusters which has very few number of points inside it, then that is considered as the outlier, and that points are deleted. I shall discuss it in detail in the point that after partial clustering, there are some cluster in the partitions which are having less than certain threshold limit of points. These considered as the outlier, and these outliers are eliminated. After eliminating the outliers, the remaining partial clusters are clustered together to form the larger number of the clusters. And when the final clustering take place, then we label these data, and this considered as a final cluster. So they are basically 6 steps: draw the random sample, and after that partition the sample, and after partitioning the sample, we perform partial clustering inside the partition, and the partial cluster that are having less than certain amount of number considered as the outlier. These outliers are eliminated, and after these elimination, the partial cluster which are left are again merged together to form the larger size of clusters. I shall discuss you on which basis they are merged together, and after labeling, and finally they are labeled, and that form the final cluster. So these are the basic 6 steps that are used in the cure algorithm. So here the step here in the diagram I'm going to show you. The first, we take the sample of the data initially, and we partitioned it into the 3 partitions. In the each partitions, these are done by taking the random representative elements, and taking these random elements, all the data points which have not been taken as a representative element get attached to the sum of the representative elements. Here we have taken 2 representative to represent a cluster. In this way, that there are 3 partial cluster has been formed. In the partial clusters, after the cluster perform, each partial cluster is having 2 representative elements, and the 2 partial cluster whose representative elements are closer to each other get merged. Here the 2 clusters, the representative elements are close to each other, so they have these 2 partial cluster merged together, and in this way there are 4 representative element inside it. But out of these 4 representative, we select 2 representative, so that in this way the number of the representative of the final merged cluster is same as the initial ones. So we select the representative of for the newly created clusters from the set of the previously selected representative elements. Now the first step, that the advantage of the Cure algorithm, because it is very efficient, is because it takes just 2.5% of the original data to perform the clustering. In this way, we are dealing with the data warehousing where the data size is so large and it is taking just 2.5% of the data. Yes, it is using a representative element representative element selection algorithm that takes some time, but in comparison to the data size it uses to form the final cluster is very small, as it is only 2.5% while other take 100. So it is very much very efficient, and its execution time is lower, and it's cost the least. For speed up, the algorithm operation is can be fitted into the main memory, and in this way the overhead of generating the in comparison the generated cost of generating the random sample is very small. So it is very efficient technique, and we just instead of taking all the data, we just select the random sample of the data. After that, in the second step in partitioning, we suppose there are 10 data points, then they are partitioned into the p partitions. So each has the n by p number of points. These partial clusters, these partitions are again partially clustered until the final number of cluster created reduces to n by p into q with q greater than 1. It means that if the number of the points inside the partial cluster is greater than a limit, then we repartition it, and if the number becomes smaller than the value, then we do not perform any more partial clustering. The advantage of partitioning is the reduced execution time. So in the partitioning step, we just take the representative element. Each element which are not representative element get attached to some representative element with which they are closer, and in this way in this way we partial clusters the each partition. When the two partial clusters merge together, then we select the representative element part out of the out of the previously selected representative element, and suppose there are n number of representative in each n number of each representative element in each of the clusters. Then after their merging, the out of the total 2n representative element, we shall select the n number of representative element. And again, after selecting n representative element, we perform the process of shrinking the representative element. Then these points are shrank toward the mean of the cluster by a fraction of alpha. And if alpha is equal to 0, the algorithm behavior becomes similar as all point representation. In this situation, when alpha is equals to 0 means that there is no shift towards the center, then this becomes equal to the all point representation. And if alpha is equals to 1, cure is reduces to the centroid based approach. So for alpha is equal to 0, it's equivalent to all point representation, and for alpha is equal to 1, it is equivalent to centroid based approach. So this way the outlier, in this way when the shrink toward the mean, the outliers are typically farther away from the mean of the cluster. So the outlier are easily detected by doing this. Um, I've told you that when the two cluster with the C scattered representative, each the finally merged cluster will have two C scattered points, and out of them we shall select C representative element. So we do not need to rerun the selection representative element selection algorithm for each merger. So it's uh, time efficient, and the time new points are fairly scattered. Here in the going back to the previous diagram, we see that the two class representative of the finally newly created newly created cluster have been selected from the previously selected four representative element, and these two representatives shrink toward the mean by a fraction of alpha. So shrink representative point. Now the handling of the outliers. Suppose a point is far away, then it will be far away from the rest of the points, then definitely the less number of the point will attach to it rather than the element which are in denser areas. So if a point is uh, so if there is a point that the number of point in number of point in its proximity are less than rest of the number, then it is considered as the outlier. Though, so the cluster which are growing very slowly are identified as outlier and eliminated. And at the end of the growing process, very small clusters are also eliminated and considered as the outlier. So this technique is very efficient in handling the outlier. Uh, this method is different from Birch, in which we use the centroid based approach, and it's Birch like algorithm work on consider as centroid consider data to be scattered in the spherical shapes, and it normally split the cluster which have non-spherical shapes. So it is not efficient to handle the irregular shape. I am talking about the Birch technique. But in the Cure algorithm, it can easily handle the irregular shapes, and Cure is more than 50% less expensive because it uses only 2.5% of the original data. So while we are dealing with the data warehouse, which are of very huge size, then this technique become very efficient in comparison to the Birch algorithm. And it can also work on non-spherical shapes, and it is a very good execution time in presence of large database using the random sampling and partitioning method. And the outlier can be easily detected with this technique.